Why is it that during winter it's not uncommon to have days with abnormally high temperature and summer-like weather, but in the summer it never drops to winter-like weather for a day?
Lots of incomplete answers. Look at this graph of solar intensity versus latitude. As you can see, the summer pole receives about as much sunlight as the equator, actually, slightly more because of the 24-hour days in the Arctic Circle. On the other hand, there's a huge difference in energy provided to the equator versus the completely dark winter pole. As a result, there's a huge difference in temperature between the winter pole and the equator, and not so much between the summer pole and equator.
But that just explains changes in temperature versus latitude, not changes over time. So let's think about weather systems. Storms are created by the north-south temperature gradient as heat moves from equator to pole. A small amount of it is converted into kinetic energy. Heat flow causes motion, just like a very inefficient steam or gasoline engine.
When the temperature difference is large, the engine runs faster and more efficiently, creating more kinetic energy, which is to say the storm winds blow stronger when the pole-equator temperature difference is in the wintertime. The difference in solar heating creates a much larger equator-pole temperature difference than in the summer. This creates much stronger wind patterns. So you've got stronger winds, blowing a bigger temperature gradient around across the surface of the Earth.
So you see much bigger temperature shifts from day to add some examples. Here are views of temperatures and winds at the 500 mbar level in Northern Hemisphere summer, 42.29,316 last August 19th, and Northern Hemisphere winter, 42.29,316 yesterday. Colors indicate temperature contrast. Purple is colder, streaks indicate wind direction and speed.